So when we're talking about physical properties of matter and chemical properties of matter, we might need to go back for a second and talk about what is matter. We defined that yesterday in class. What are some of the things that we know or some of the things that we use to define matter? Paige, go for it.
Anything that has mass or takes up space.
Okay, so anything that has mass or takes up space. Some of the examples we talked about, does anyone have any examples of what matter would be?
Water.
Water is an example of matter.
Air.
Air. Autumn.
Ice.
Say it louder.
Ice.
Ice. Okay. Dane?
Plastic.
Plastic. Good. Okay, so when we talk about physical properties of matter and chemical properties of matter, these are things that matter has. They have both physical properties and chemical properties. Okay, so when we say physical property, we're going to define that by something that can be observed. So a physical property can be observed, and it can be observed without changing it into another substance. So it doesn't change the substance or change it into another substance. I'm going to put it in quotes, meaning it, without changing whatever matter it is that you're looking at into another substance. I'm going to underline this word substance. What I want you guys to do at your table when you get this definition recorded, review what does the word substance mean. We talked about that yesterday in class as well. So what do we mean by a substance? Landon's group is going to speak first. What did you guys come up with, Landon, for substance?
We came out that it's a single kind of matter that is pure.
Okay, so when we say something is pure, what do we mean by that? And this is one of the things that I think students struggle with most. We'll come up with a definition, but we won't necessarily know what our definition means, right? So in our conversations with each other, we're really going to work on, if we give a definition and we think we have an idea of what something means, do we know what everything in that definition means, right? Because something being pure is extremely important to understanding matter. Okay, Dane, what do you think?
I think pure means like stuck in there forever.
Okay. So Dane thinks it's stuck in there forever. Paige? Something you can see. Can we see air? Okay. And air is an example of something that can be pure. Okay.
Something you can see through.
You could possibly see through, but that doesn't necessarily mean pure in the science terms. Sometimes we think of pure in kind of a slang or society, but we're talking about pure as in regards to matter and science. Go for it, Bailey.
Something you can't see. Like,
Well, you can see it. Remember we said salt is an example of something that's pure. Can you see salt? Okay, so it is some things that you can see. Jess?
something about like
All kinds. Saban?
it's completely made out of something.
Often that's what students think, but it doesn't have to be made only out of one thing. We did say yesterday that pure substances can be made out of more than one thing. Salt is made out of, anyone remember?
Sodium chloride.
Sodium chloride. If it's made out of sodium chloride, that means it's made out of sodium and chloride, two different things. But to be pure, and you might want to add this to your notes, maybe underline the word pure if you're struggling with that, and put an arrow for a definition. When we talk about something being pure, what we mean, and I'm going to write this down up here in the corner. So to be pure, we're talking about something that cannot be separated into another substance. So it's pure if it cannot be separated into another substance. So salt will always be salt. We don't ever take salt and separate it without extreme measures. I mean, with extreme measures, yes, you can separate sodium and chlorine, but just out of typical everyday exposure, salt does not separate it on its own. So pure cannot be separated. Excuse me. Into other substances. That the physical properties cannot be made into another substance, we're saying it can't be made into another composition. It's going to remain that way regardless of what we're using to observe that. Okay? The chemical properties, on the other hand, those are going to be characteristics that describe the ability to change. So you have your physical properties that don't change, and it's an observation. It's something you see, smell, right? You use your observations for. Chemical properties are characteristics that describe something's ability to change. And we're going to work on some examples of these to help you guys out here in a second. But characteristic of a substance. That describes its ability to change into another substance. So raise your hand if you've ever seen rust on something. So everyone in here has seen rust on something. Was the rust always there? Have you seen something go from not having rust to having rust? So that would be an example of a chemical change. Okay, it wasn't there before. It's a different substance. Okay, is rust adding mass or taking away mass? Meaning, does it add more quote unquote weight or does it take away weight from something? What do you think, Sloan?
Take away.
Take away? If you agree, raise your hand. So we got 1, 2, 3, 4, 5, 6, 7 people who agree. Okay, if you disagree, raise your hand. If you're disagreeing, you're saying rust adds weight or adds mass. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of you that disagree with that. And I would be on that side of it. Rust actually adds mass. It's changing the substance and it's adding to it. A lot of us think of rust as eating away, and that would actually be corrosion. Rust often is right by things that are corroding. So how many of you ever seen like the backsides of trucks or vehicles over the wheel wells, right? Lots of road salts, lots of things that kind of get kicked up in there, and you'll see that kind of rusted. The rust is not actually the part that's taking away. It would be the corrosive effect that's going on there. So looking at the sheet of paper that I gave you, and just leave it on the desk for now, you're going to see a bunch of these little images. All of these that are on my screen are on your piece of paper. This activity, what you're going to do with it is you're going to cut all of the squares apart. So you'll get half the sheet, you're going to cut all the squares apart, and you're going to sort them. So if you look at your handout that I gave you, that's called Properties of Matter Cut and Paste, it looks like this. It kind of gives you a hint about the number of physical properties out of all those images and the number of chemical properties. So four of these images are going to be what? Chemical or physical? If you look at your sheet, it tells you. Dane?
Chemical.
Yeah, 4 of these are chemical. The rest are what? Autumn? Yep, the rest are physical properties. I do not want you gluing them down. Okay, to be very clear, I do not want you to glue them down. I want you to sort them, and you can talk amongst your tables to determine that. But when it comes to gluing them down, we'll make sure you have them right before you glue them down. And we'll kind of talk about them, okay? So when I say go in your groups, you're going to look at those, get them cut out, and start sorting them. Go. But when you're looking at the options on this screen or your individual little sort cards, what you're trying to figure out essentially is what are the 4 properties that would be considered chemical properties. So chemical properties, again, are things that actually change what that substance is made out of. The physical properties do not change what that substance is made out of. So again, the example that we used was melting, right? Melting and freezing down here. Melting and freezing. If you melt an ice cube, it melts into water. If you freeze it, it's solid water. It's still made of hydrogen, H2O, right? Hydrogen and oxygen. Doesn't change what it's made out of. Rust, on the other hand, where's the rust one at? Right here? Yeah. Rust, on the other hand, is actually changing what that sign is made of. It's taking part of the element that that sign is made from, and it's reacting. So iron will react, and it'll rust. So it changes the chemical formula, the chemical makeup of that sign. So what we're trying to figure out right now are what are the 4, aside from rust, what are the 4 chemical changes that we have listed? So this is 1. What are the other 3? Electric conductivity is not going to be one of them, and here's why. Electric conductivity is just the ability for electricity to travel along a wire. If you think about all the wires in your house, all the wires to the lights right here in the classroom, do you think to run the lights or to plug in your computer, it's changing anything within that wire? Nope. It just has a property which allows those electrons to travel along the wire. Okay, so it's not actually changing what it's made of. So if feeling something doesn't change what it's made of, then we know that texture is not one of them. So texture, we're going to cross off. It is not a chemical property. It's a physical property. It's something that we see, but the texture of something does not change what it's made of. So reaction with sulfur is a chemical property. It is something that changes what it's made of. So you see this happen a lot with spoons. I don't know. A lot of people don't have these anymore, but spoons that are actual silver spoons, made out of silver, they tarnish quite often. And so some of your parents or grandparents might have spoons that they polish. They polish the silver. Raise your hand if you've ever seen that, where they polish the silver with like a cloth. That's because that'll prevent them from tarnishing, or at least help slow it down, and it'll help prevent that change from the spoon into another substance. Heat is not going to be a chemical property. So think of it this way. Water, if we heat it up, what does it do? It boils, but does it change out of its form of water? No. Does it change it into something else? No. Malleability, what that one is, that is the ability for metals to be smashed and shaped. So if you take a sign and you hit it with a hammer and you indent it, that would be malleability, meaning that metal could be bent. Did that change what that sign was made out of? No. So it didn't change what it was made out of, so that means, again, that is not a physical property. Solubility is not a chemical powder. Solubility is just the ability for things to be broken down into a liquid, but once you dry it back up, it's still there. So salt, how many of you have ever had salt in water, let the water evaporate out, the salt was still there? Okay. Jaden? Flammability is a good one. Flammability does quite often change the chemical makeup of something. So when Sabin said the other day, fire, and I said, remind me of fire later, this is why I wanted you to remind me. Because fire is a chemical property of matter, okay? If it catches on fire, which is what I thought Carter was going towards, then it does change the properties of that. So if your house wires do catch on fire, as in they're flammable, the flammability is high, they catch on fire, yeah, that would be chemical property. So it's too bad Carter didn't make that connection earlier, right, Carter? Okay, good. Acidic or basic, so the pH, yes, absolutely. That can change what a substance is made out of. How many of you have ever heard of an acid? Raise your hand if you've heard of an acid. A lot of you have heard of an acid, right? How many of you have ever heard of a base? A liquid base. Yeah, so we've heard of maybe a bass like a guitar or a bass drum. But when we're talking about an acid or a base, we're talking about the amount of hydrogen ions that are present in that liquid. So we'll get into pH here actually in a couple weeks, and it is something that plays a role. How many have ever heard of acid reflux? So people are eating and all of a sudden they have acid reflux. That's because of a pH imbalance in your stomach. Okay, so it has a lot to do with everyday life and just even understanding your own body, because I don't have problems with it, but other people do, right? And if you do have problems with it, you kind of want to know how to counteract it or how to fix it.